Hey guys, it's been a little while since I've posted any updates and just had quite a few things going on, but hopefully we're going to get back into it here. So you'll see behind me I have a larger battery pack. So this battery pack is 8 cells wide by 2 cells deep. Now you'll remember in a previous video I did build a pack of 8 cells with steel bands, however I ran into a couple of issues with that particular design. So here is one of the two 8 cell battery packs I had built with the steel strap. Now if you look down on the bottom here, you can see the cell on the left side is actually lifted up off the board. And if you go across, you can see the center cells are resting on the board just fine, though when you go towards the right, the end cell is lifted up off the board again as well. Now at first glance, I thought, okay, maybe this top strap is tighter than the bottom strap and applying more compression, squeezing them together. But that is not the case. The top strap is actually looser than the bottom strap. And that means that the cells are wider across the base than they are across the top. So if I measure this battery across the bottom, I've got 23 7/8 of an inch. And if I measure this battery across the top, I've got about 23 1/2 inch. So that's quite a difference between the top measurement and the bottom measurement. Now I don't quite know what the reasoning for that is, whether it means the cells have expanded on the bottom as a result of charging and discharging, maybe they weren't compressed right. Maybe that's just the way the cells were when they came. I didn't compress them before I had top balanced them, so I don't know if that's a result of the top balancing I had done or... And one other thing we know as well is that these cells are a 1/2 millimeter wider at the top state of charge versus empty. So I don't know if once I discharge these cells if we're going to see the same expansion or if that's just a result of the current state of charge. And the other issue I have with this design is that the strap is tighter on one side versus the other side. And the reason for that is this 90-degree corner here is a very sharp turn, so this is causing more tension to be exerted on one side than the other. Now if you look at how a commercial battery pack is built that uses metal straps like this, the plastic is rounded, so the strap can sit in and slide easier on that rounded section. Now of course I could design something like this myself. You know, the costs start to add up more and more and more to the point where it no longer makes sense to use this metal strap. So the new design I'm currently testing and will likely go with is a threaded rod approach like many of you had suggested from the start. So I've got 8 cells and these are wired in 2 in parallel and then in series just like the original 8 pack. So this will essentially be an 8S2P battery pack or 24 volts nominal. I still have the same white cutting mat spacers in between the series pair, still using the same threaded rods, the same bus bars, the same flange nuts. Nothing has changed with regards to that aspect. And on the ends here I have 1-inch angle aluminum. This is 1/8 inch thick. I used a 1/4 inch threaded rod. This is 1/2 inch plywood on the sides and there's also a piece on the bottom. And I put the threaded rod through a piece of polyethylene tubing for insulation. It's just standard 1/4 inch inside diameter by 3/8 outside diameter. Picked it up at the hardware store. And you can see I've got 2 threaded rods on the left. I've got 2 threaded rods in the middle and 2 threaded rods on the right. So the only variable I still have to figure out is how tight I want each of these threaded rods to be. I currently have the outside 2 threaded rods tightened to 50 inch-pounds of torque, and I have the center threaded rods tightened to 100 inch-pounds of torque. That seems to give a good amount of strength. I've seen people suggest using something as low as like 10 inch-pounds or something like that, but I don't think that's enough compression in my opinion. You know, I want this to be a strong, rigid pack that doesn't flex when I move it around and not too tight that it's then damaging the cells. So I did have a recommendation to not care about torque at all and just tighten so the distance is the same in all 4 corners. But even with both this top and this bottom rod both being at 50 inch-pounds, I am seeing 23 3/8 inch on the top and 23 1/2 inch on the bottom. So with both of these threaded rods at the same torque of 50 inch-pounds, there is still an 1/8 of an inch difference between the bottom and the top in terms of compression. I've seen some people recommend using springs at each end and stuff like that to ensure constant pressure all the time. I don't think that's a bad idea, but at the same time I've never seen a commercial battery builder use springs. I'm sure they have a method or a formula to determine the tightness of the metal straps they put around them. They are measured and calibrated, but for the purposes of DIY here and the low C rates these cells are going to see, I don't foresee this being a problem, but we'll see. So yeah, that's just a quick update where I'm at with these batteries currently. I still have to take apart the other 8 cell battery pack with the steel banding and rebuild it as a 16 cell like this one. The only downside to this really is the weight. This battery pack weighs just under 200 pounds, so I'm going to need 2 people to help me lift it off of this bench and into my shipping container. I don't think that'll be a problem though, because you don't move this battery pack around every day. Once it's installed, it's only going to come back out if I see signs of failure and it needs further inspection. Also, I did order 32 more of these batteries, which will put me right at 64 cells, and should be enough capacity that I can completely replace the 18650s I have currently with these lithium iron phosphates. So yeah, please hit that like button before you go. Questions or comments, you can leave those as well, and thank you for watching.